As dawn breaks over the range at Woomera, preparations for today's firing of Skylark are well underway. The rocket nose has been brought to the launcher first and is hoisted into position between the launcher rails. This nose carries the complete load of instrumentation, telemetry sender, tracking beacon, Doppler transponder, power supplies and the special high-altitude instruments. The nose cone is of stainless steel to withstand severe heating at speeds near Mach 6. With the nose in position, the launcher crew, still muffled against the early morning chill, leave the launcher. Now for breakfast. This is the Raven motor, 15 feet long, 17 inches in diameter, weighing almost a ton. It gives a nominal thrust of 5 tons for 30 seconds. The complete rocket is dart stabilized by 3 fixed fins which slip over the rear of the motor and are bolted in position. Skylark has no movable control surfaces and it is not guided in flight. The launcher is a massive structure standing over 80 feet high. The tower is supported in gimbals and shortly before each firing it is laid in a particular direction to make allowance for the measured winds. As preparations for the firing continue, the advantages of using the Raven motor become very apparent, for there are none of the problems met with in liquid fuel motors. No corrosive liquids, no alcohol or liquid air to be pumped. Once in position it can be left for hours or even days if the firing has to be delayed. The rocket nose, already poised above the motor, will be lowered into position and secured to the Raven. Skylark will then be complete, and when the shore supplies have been plugged in, we'll be ready to start the firing sequence. Warning flags are hoisted and the range is brought into readiness. In the instrumentation block, the telemetry receivers are checked. And the signals now being received from the rocket are examined. Scores of range staff will be involved in the operation, and all are brought in touch on the communications network. Timing signals to all posts are synchronized. All the resources of this large rocket range at Woomera are called upon to cover the firing. Tracking radars and high-speed cameras are checked and made ready. In the initial stage of its ascent, Skylark will be tracked by a number of kinetheodolites, some requiring 2 operators to pick up and follow the swiftly moving target. This Ascania kinetheodolite is primarily used to determine the missile position in space. The high-speed Vinton camera provides a fast record of the early flight, and in the event of a failure can detect occurrences which might otherwise pass unnoticed. A variety of cameras of different focal lengths and speeds is required for complete tracking, and to each a particular function is assigned. The sub-controller calls all posts to attention. And now the controller takes over, giving detailed instructions for the countdown.
Stand by for Skylark firing sequence.
At the launcher, the rocket stands poised for the firing, whilst the launcher crew clear the apron. At the moment, the shore supplies are still connected to the rocket, but in a few moments the plugs will be ejected and the internal supplies will take over. 30 seconds to go, switch to isolate. Check telemetry. 20 seconds, smoke rocket away. Switch telemetry recorders. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, fire! With rapidly mounting speed, the Skylark rocket thunders into the sky. Cameras follow it as far as possible, but even when far out of sight, ground receivers continue to follow the radio beacon, plotting the rocket's course high into the upper atmosphere, where, for a few brief minutes, scientific measurements are made in the new and strange environment of outer space.